Hello, this is the luckiest maths teacher in the world. Thank you for tuning into this video in which we will take recurring decimals from different bases and convert them to base 10 numbers. So to do this, we need to use what we learned in the previous lesson, the sum of a limiting geometric series a over 1 minus r. Because if we have something like 0.5 recurring in base 8, this actually forms a limiting geometric series. If we write it in expanded form, this is just 5 over first column's eighths. The next column has 8 squared on the bottom and then 8 cubed on the bottom and so on. So this number is just equal to this sum here. Now, because it's recurring as indicated by this dash, it goes on forever in that pattern. Now this infinite sum here will converge to a limit because r is 1 over 8. If you take any term, you times by 1 over 8 to get the next term. So the sum of these infinitely many terms is simply first term on top, on the bottom is 1 minus r, which as I said is 1 over 8. So you can put that on your calculator, you simply get 5 over 7. That's the fraction in base 10. And if you want to convert that to a recurring decimal in base 10, all you have to do is put that on your calculator. It's 0.714285 and this pattern recurring. So let's look at 0.b recurring in hexadecimal or base 16. Remember that b in base 16 is equivalent to 11. So this is 11 over 16 plus 11 over 16 squared plus 11 over 16 cubed and so on. Because it is recurring, it follows this pattern forever. This is another limiting geometric series. So the sum of the infinitely many terms, you put the first term on top and on the bottom is 1 minus 1 over r. Here r is 1 over 16. So all you have to do now is put that in your calculator and you actually get 11 over 15 in base 10. So if you want to convert that to a decimal in base 10, you can just use your calculator. It's 0.73 recurring in base 10. Let's now look at some harder examples. So let's try this here, 0.32 recurring in base 5. So we have a 3 in the 5s column and a 2 in the next column, 3 in the next column, and so on. So this one is actually harder because what we have here isn't quite a geometric series. To see that, if you divide this term by this term, you get a different answer than if you do this term by this term. So what are we to do? Well, we can actually split this up into two series that are geometric. All the 3's make their own geometric series. So 3 over 5 plus 3 over 125. The next one will be 3 over 3,125. This here is a geometric series. So just as all the 3's form their own geometric series, so too 2's. So that will be 2 over 25 plus 2 over 625. The next one will be 2 over 15625 and so on. So I'm just going to calculate this limiting sum and add my answers. So for this one here, this is a limiting geometric series because it's geometric and r equals 1 over 25. This divided by this divided by this is 1 over 25. So the limiting sum is first term over 1 minus the value of r. So for that, I actually get 15 over 24, which is equal to 5 over 8. So now I'm going to do the same here. This limiting sum is first term over 1 minus r. Again, r is 1 over 25. So this, if you put it in your calculator, is actually 1 over 12. So my final answer is 5 over 8 plus 1 over 12. So if you put that on your calculator, the answer in base 10 as a fraction is 17 over 24, and you can just use your calculator if you need to convert that to a decimal. It's 0.708 and the 3 is recurring. All right, let's look at one more example. So let's look at 0.121 recurring in base 3. So let's write it out in expanded form. So first column's 1, then it's a 2, then it's a 1 again, and then we start the cycle all over again. 1, 2, and then a 1 again. So once again, this is not a geometric series, because if you were to take any term and divide by the previous term, you would get the same number. But each of these has its own geometric series, so we actually need to add up 3 this time. So for this first one, let's look at every third number. 1 over 3, 1 over 81, the next one will be 1 over 2187. Now we'll look at all the 2's. 2 over 9, 2 over 243, the next one will be 2 over 6561. And now we'll look at the last one, this last one here. So that'll be 1 over 27, next one's 1 over 729, next one's 1 over 19683. So each of these here is its own limiting geometric series. So let's look at the first one here. So the limiting sum is first term over 1 minus the common ratio, which is 1 over 27. For the second one, the ones with all the 2's, it is the same ratio but a different starting value. And for the third one, it is again the same ratio but a different starting value. So we can put all of this in our calculator. First one gives us 9 over 26. The next one gives us 6 over 26. And the last one, 1 over 26. So all of this adds up to 16 over 26, or 8 over 13. So that is the fraction in base 10, and we're done. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.